Okay. Okay, let's go on. Okay, let's do a quick check exercise. Okay, although I haven't end lecture, never mind. Right? Okay, true or false questions. Okay, if A plus 2i equals 1 plus bi, does it mean that A is 1 and B is 2? True or false? True or false? True or false? Okay, the answer is false. Why? Why? Did I say this? Nah. This is not called 骗. This is called checking your understanding. Okay? So I didn't say this, not stated, so you cannot assume. Okay? This is something I've been reiterating over and over and over again. Okay, but you see, it's very easily lost one. Real numbers are not complex. True or false? True or false? What is a complex number? Any number that's of the form a plus bi, right or not? So are real numbers complex? Yes, because a plus 0i lah. Okay, so yes, false. Okay, next. As their name suggests, the real part of a complex number is real, while the imaginary part of a complex number is imaginary. True or false? So if I have a real part of x plus iy, it is x. Is it real? Yes, right. If it's imaginary part of x plus iy, is it purely imaginary? Is equals to y. So it is real. Okay, so the imaginary part of a complex number is real. The statement here is again false. See? Okay, very simple things. Okay, the product and sum of a complex number with its conjugate are both real, while the difference between a complex number and its conjugate is purely imaginary. True or false? True or false? This is actually something to do with those two students who I caught and answered questions just now. The self-reading section. Remember, z times z conjugate, z plus z conjugate, z minus z conjugate. Is this statement true or false? Statement is true. Okay, the statement here is true. Okay, go back and see. Alright, okay. Okay, so this is what we have done today. So you just look through. Okay, next. No, haven't next lesson. Now we go on to the next part. Okay. Okay, let us just do a quick recap. Okay, you see the answers already, but never mind. Okay, we just quickly run through. Okay, now. Okay, we are going to revisit this particular topic that you learned. Listen. Okay, we are revisiting this particular topic in secondary school called remainder and factor theorem. Remember? The one where you have to factorize cubic polynomials. Okay, so let us just recap on some definitions because we need this for this part of the lecture. Okay, what is meant by a polynomial? what is meant by a factor of a polynomial, a root of a polynomial, and what is the factor theorem? Do you remember all this? No. Okay. Okay, so let me just jog your memory a bit. Okay, now this is what is meant by a polynomial. Okay, so as long as you have x to the power of something, okay, something like x to the power of something plus something times x to the power of something, so on and so forth, that is a polynomial. Okay, but that power must be a non-negative integer. Okay, that power must be a non-negative integer. So I cannot accept things like this. Okay, I cannot accept things like this. Okay, clear? Okay, is this let's see, is this a polynomial? Three times cosine x whole thing to the power of 6 plus x squared. Is it a polynomial? No. Okay, so your polynomials cannot have what? Cosine, sine, ln, e to the power of x. All these cannot. Must purely be x to the power of something. X to the power of something. Okay? Can Okay, next. What is a factor of a polynomial? Very simple. Okay, I'll show you this together with roots because this is the part that people always confuse. Now, shh. When I factorize x squared minus 1, I will have this, which all of you know. Can I assume that? Okay, now, a factor is something that looks like this. It's just like how you learn factors and multiples of whole numbers. Right? When I say 3 times 4 is 12, I can say that 3 is a factor of 12, right or not? So same idea, just that now it's in the context of polynomials. Okay, so this is not to be confused with roots. Okay, the two are not the same. Okay, a root of a polynomial is a value of x such that the polynomial becomes 0 at that value of x. Okay, but there's a relationship that is detailed in factor theorem that says this. If a number is a root for a polynomial, okay, then x minus that number would have to be a factor, and vice versa. Okay, so even if you may forget a lot of things today, please remember factor and root not the same. Not the same, okay?